Welcome. Let's take a look at a couple of integrals that require the technique integration by parts. We can see the formulas for integration by parts on the lower left of the screen. The first integral we have is the integral of x times e to the 6x dx. And so this is an indefinite integral, so we will be using the formula that's highlighted that says the integral of u dv is equal to u times v minus the integral of v du. So let's go ahead and get started. So the first thing we need to do is to look at our integrand here, this x times e to the 6x, and determine which of those two quantities, the x or the e to the 6x, is going to play the role of u versus dv. And when we look at that, we want to be strategic about how we make that choice. And so we're going to choose a u and a dv. And when we make those choices, typically we're looking for a pairing that makes the resulting integral, the integral of v du, we want that to be at least no more difficult than the original integral, ideally simpler than the original integral. And so one possible choice would be let x equal u, and then e to the 6x equal dv. Now if we were to do that, then u would be x, and dv would be e to the 6x dx. And then we look at the result of that. So if u is x, then du is the derivative of u. So the derivative of x is 1 dx. And v is basically the antiderivative, or the integral of e to the 6x dx. Well, the antiderivative of e to the 6x dx is 1/6 e to the 6x. And I always check myself when I do integrals like this, asking myself, what is the derivative of 1/6 e to the 6x? Does that end up giving me that original e to the 6x? And it does. So there we go. So now we put the pieces together and make the determination, was this a good selection? So this is going to be equal to the integral of, it's going to be equal to u times v. Well, u is x, and v is 1/6 e to the 6x, minus the integral of 1/6 e to the 6x. So that's my v, the integral of v du. Well, my du is 1 times dx. So I look at this integral I've just created, and I ask myself, is the integral of 1/6 e to the 6x, is that no more difficult than what I started with? And I would say yes, because I no longer have this x multiplying e to the 6x like I did in the original integral. So that appears to be a good choice. So we continue on. So I've got x times 1/6 e to the 6x. So multiplying those together, I'm going to have a denominator of 6 and a numerator of x e to the 6x. For my integral, I'm going to go ahead and factor out that 1/6, bring it in front of the integral, and then I have the e to the 6x as my integrand. So at this point, I've got x times e to the 6x over 6 minus 1/6 times the integral of e to the 6x. And what I can notice at this point is that this integral I'm left with is basically what I had to do way up here when I did my integration by parts and set up my u dv and my v du. So I'm just going to use that information to help me finish out this integral. So continuing on, this equals x times e to the 6x over 6 minus 1/6 times, and I've already done that in antidifferentiation up here, so I'm going to have a 1/6 e to the 6x plus, now I'm done with the integration process, and this was an indefinite integral, so I'm going to have my constant of integration. At this point, we're basically done. I'll go ahead and simplify that second term there and get x times e to the 6x. That was our first term. And then we've got minus, and then I've got a 1/6 times a 1/6. That's going to give me 1 over 36 times e to the 6x. So I'm going to write that as e to the 6x over 36 plus c. And there's our antiderivative for the integral of x times e to the 6x dx. That antiderivative is x times e to the 6x over 6 minus e to the 6x over 36 plus constant of integration. Now let's take a look at our second example here. This involves a definite integral, so we have limits of integration. So we've got the integral from 1 to e of x times the natural log of x dx. And notice in the lower left corner here we have highlighted the general formula for performing integration by parts for a definite integral. So we have the integral from a to b of u dv is equal to the product u times v evaluated from a to b minus the integral from a to b of v du. So that's the structure that we'll be working with for this particular integral. So let's go ahead and get started. Now, of course, we want to choose our u and our dv so that we do not make the resulting integral in the v du part of the process more difficult. And so for this particular problem, we basically have two choices. We could let x equal u and ln of x dx equal dv. What would the result of that be? So if we let x equal u and ln of x dx equal dv dx, what would that mean? Well, du would be the derivative of x, so that's 1 dx. Dv would be the antiderivative of ln of x dx. And that's not an obvious antiderivative. It's actually not a simple antiderivative. It actually requires using integration by parts itself to find out what v is equal to. So at this point, it's an indicator that I probably haven't chosen the best pairing. So we're going to back up and switch things around and see if that improves our situation. So if I switch things around and I let ln of x equal u and x dx equal dv, then let's see what happens. So ln of x is u, so du would be 1 over x dx. And see, the derivative of the natural log is much simpler to find than the antiderivative. And let's see, dv we said would be x dx, so v would be Antiderivative of x is not too difficult. It's x squared over 2. So at least finding the u and the du and the v for the integration by parts process is much simpler with that pairing. So let's go ahead and continue on and hope that that actually works out to be the best pairing. So equals, all right, so it's going to be u times v. So we're going to have x squared over 2 times ln of x. And then we're going to evaluate that between x equals 1 and x equals e, minus the integral from 1 to e of v du. So we'll have x squared over 2 times 1 over x dx. And actually, that's not too bad because this integrand is going to simplify. Let's see, x squared over x just becomes an x, so this becomes an x over 2. And that's a much simpler integrand than what we started with, so that's a good thing. All right, so in this first term, we're going to substitute e for x. So we've got x squared over 2 times ln of x. We're substituting in e and then subtracting what we get when we substitute in 1. So we're going to have an e squared over 2 times the natural log of e minus 1 squared over 2 times the natural log of 1. We'll simplify that in a minute. Equal or minus the integral from 1 to e of x over 2 dx. So moving along, we see that in our first term we have e squared over 2 times the natural log of e. We know that the natural log of e is 1, so we will substitute 1 there. And we see that we have the natural log of 1, and we know that the natural log of 1 is 0, so we will substitute a 0 there. So we have e squared over 2 times 1, so that's going to be e squared over 2, minus, and we have 1 squared over 2 times 0, so that's just going to be a 0. Minus, and now we do the antiderivative of x over 2. That antiderivative is x squared over 4, evaluated from x equals 1 to x equals e. I do want you to notice that I put this in parentheses, so when I do that evaluation, I am reminded that this subtraction here in front of that definite integral is applied to the result of that integration process. So at this point we can go ahead and substitute in for that last integral. So we have e squared over 2 minus, and now we're going to do that substitution. Substituting minus the grouping or parentheses, substituting in e, we get e squared over 4 minus substituting in 1 squared over 4. And so what do we have here? We have e squared over 2 minus e squared over 4 minus 1/4. Now we're nearly done. We can simplify those first two terms involving the e squared. So we're going to get a common denominator. We'll multiply the first term, the e squared over 2, by 2 over 2, so we have a common denominator. And then we're going to end up with 2e squared minus e squared over 4 minus 1/4. So then our final result, simplifying that numerator, is e squared over 4 minus 1/4 is our final answer. I hope you find this helpful.